We'll see if anybody trickles in. So designer engineer, I think this is a question I've seen kind of asked throughout my career. And when I was asked to put together something for Startup Week, I thought this might be an interesting topic. So hopefully I can share some of my experience of dealing with designers and engineers during my product development career. So just a little bit about me. My name is Mike Nickel. I actually work locally here in Denver for a company called BOA Technology. We make performance closure systems for footwear. Many people have seen us cycling shoes, golf shoes, snowboard boots. For us, it's really focused in the performance side of how do we take, these top athletes and push something that's, already at the top even higher. I graduated from University of Cincinnati way back when, in '97. During that time, while I was at Cincinnati, just based on their program, you actually do 6 internships. So I got to experience some different things, Intermetro Industries, Jerry Baby Products. Actually, Jerry Baby Products, I don't know if anybody's from Denver, but they were actually here. I think they sold to a company called Evenflow. So that was my first taste of Denver, first time I'd been out here, as I'm originally from Cincinnati. While I was at Jerry, I actually got my first mechanical patent, which, as a college student in industrial design was, this kind of interesting thing. Last internship I did at NCR Corporation. I don't know if everybody knows what NCR is. Sure, you've used a product before. If you've ever pulled cash from a cash machine, that's NCR. And again, we've already established, it was a long time ago when I got out of school, I was working on this interesting new technology, working on the experience of self-service checkout. So it's really interesting to see some of those things you worked on years ago that are just full bore. Yeah. After I got out of school, I decided that I wanted to spend some time as a consultant. So I was really looking at some different consultancies, ended up at Brooks Stevens Design. Brooks Stevens, if you don't know about that consultancy, established back in the 30s or 40s and kind of considered one of the founders of industrial design. I didn't mention that. When I graduated from Cincinnati, I got a degree in industrial design. A couple of us already talked about that, sorry. While I was at Brooks Stevens, great as a consultancy. I got to experience all kinds of products, large projects, big products. We're working on scanners for luggage for airports, post 9/11, and then all the way down to small key fobs for cars. Got to work with a lot of different big name corporations, Herman Miller, S.C. Johnson, Remington Shavers, and Miller Brewing. We had done some different bottle packaging stuff for those guys. So just all kinds of different products, all different industries. After about 9 years, got a little tired of it, just from the fact that when you're in a consultancy, people will typically hire you for the front end exploration, and you don't really work through the back end of a project. And so I wanted that experience. So I moved on to one of my customers, Remington Shavers, and came on there and found myself as the head of women's hair care, head designer for women's hair care, which was a great experience for me because it really puts you in an empathetic spot, like really trying to understand the customer. These aren't products I use, they're not products I'm going to use, but really having to understand that consumer so that I can connect the dots on those products. And then I was only at Remington for a year when I got a call from this small startup in Denver, BOA Technology, and it was one of those where I was like, I don't know if I'm going to go out there and check this out. I don't know if this is interesting to me, but came out to Denver because another friend of mine was also looking at a job there, and was really impressed by the company, and just really impressed by that vision of taking all this great athletic product and making it better, and kind of moving it to the next level. And I had always been kind of an athlete my whole life, and so it really attracted me to work on something where I might be able, every kid starts with that, I'm going to be a pro athlete someday, and quickly gets squashed. And this was like, okay, well, I'm not going to be a pro athlete, but maybe I can affect what a pro athlete does. So that brought me out here. So we're going to start with a pop quiz. Little audience participation here. I've pulled a few different products out there and just want to see if someone can look at something and understand, like, oh, that was developed by an engineer or that was developed by a designer. Figure that'd be a good place to start since we're going to talk about the two. All right, who wants to take a guess? Engineer. Okay, I'm not going to tell you, but there is an award for participation.
Wrong again.
Let's try another one. Do I have another participant? Give me a hand. Designer? All right. Last one. My final participation award. All right, the answer. An industrial designer did all these. I know that because I was the one that did all of them. So the roof rack was a project that I worked on. My neighbor, he knew I was in product development, asked for a hand on some stuff. He had a vision of something he wanted to do and didn't know really how to take it forward from that. So he asked me to give him a hand. And so we worked through his vision and bring that into a product. The second one, well, obviously I've been at BOA for a long time, and real development was some of the work I had done there. And then the final one was, again, another previous coworker who contacted me, who had started a new startup and was looking for some help on something. So I jumped in to give him a little hand on some stuff. Surprising? A little bit, maybe? So let's just talk about the definition between designer and engineer. And again, I'm looking at this from my view, so we're really talking about mechanical engineer versus industrial designer. I'm not going to well, I don't know. Can anybody see these? Back row? Okay. Okay. I'm not going to go read completely through these, but I do want to call out some key points. You know, when we look at that definition of mechanical engineer, some of those things that come to mind, and design, development, you know, I think those kind of things live in each definition in between the lines. But when I look at that engineer, the things that really call my attention are sort of the test, inspection, because in my mind, I start to think about some of the latter ends of product development and what you see at the back end. And then going through the industrial designer, some of the things I think about are, in this definition, concept of. So when I think concept, I think some of that front end. Business, you know, again, I pulled these definitions from Glassdoor, and I think business is an interesting one to have in there because not all people relate that with industrial design. But the reality is if you're developing products for mass market, you really need to understand COGS. You need to understand supply chain. There's a number of different components there. Margins. You know, what do those things mean and how they get you to a product that's mass producible? And then the last piece, manufactured products. Again, mass production. You know, when we talk about industrial design, we're not talking about, I designed this for me, I hope you like it. It's, I designed this for you. It's not about me. So how do the two look at a problem? When we kind of look at the engineering side, it's typically a functional view. How will this work? How will it be problematic? What are the risks? You know, over my years, those are the kinds of things that I typically hear in those interactions. Versus the designer is the outside in. It's a little more of that empathetic view, that experience, trying to understand the product, asking the questions, how will somebody use this? How will the experience be? And then I think an interesting one is, what does it look like? And do those aesthetics connect back to the market that the product's playing in? And do those aesthetics connect back to the function of the product? So for example, when we're designing one of our dials at BOA, we got something that someone has to turn. It has a directionality to it. And a lot of times we will bring that into the grip. We put some kind of cues within the grip so that people can look at that product and start to understand the function before they even touch it. So how do they solve problems? This one's always interesting to me because the engineering side, you're solving mechanical challenges that are going to create new solutions. And from the designer side, it's almost backwards. You're sort of trying to envision these big solutions that create new mechanical challenges. And so they somewhat counterbalance each other. We look at this cell phone on here, folding cell phone. I can imagine a experience where I deal with the experience of cell phone in my pocket, and I don't know if other people deal with it, but I feel like after I buy a pair of jeans, after 3 months, I got this rectangle in my pocket now. It kind of drives me nuts. So something that's a little bit smaller is very interesting, but it's going to create a bunch of new challenges. This is, I've heard a story from some of the different things I've heard from some of the former Apple employees, some of the talks they've given, Tony Fadell in particular. If you don't know who he is, he's one of the head project engineers that dealt with the iPhone, iPod, and then he went on to found Nest. He has a really good book called Build. Highly recommend it. It is just sort of great information throughout that book. But one of the things that he talks about is within the iPhone, they wanted a multi-touch screen. They wanted that experience of being able to gesturally affect things. But that ultimately created the challenge of there was nobody making that many screens. So they ultimately had to buy a small startup and build that into a supplier to be able to even complete their initial vision of what the iPhone might be. Working through the technical challenge is a problem. Again, different approach. Engineering, it's a mathematical approach. It's using equations to create a hypothesis and then going and building prototypes to kind of prove that. Industrial design is typically sketches and initial prototypes, sort of rapid prototypes, to build that same hypothesis. When I look at the engineering one, it's a little more direct and focused. But on the industrial design side, it's a little more iterative, a little bit of discovery, exploration. I think another interesting thing as I started to sort of dig into this subject is the education. Like what happens at the university level in these different disciplines. And so when you look at industrial design, I think the most interesting thing is, and again, this one wasn't new for me because I had been through a program, but as I compared it to what happens in engineering, it was pretty different. So within industrial design, you have these series of studios that build on each other. I originally started my college career in Northern Ohio, Bowling Green State University, doing product development, and determined, ooh, this isn't quite the right program for me after 2 years, and decided to come back to Cincinnati. Well, when you go back to Cincinnati, which has a 5-year program, because of their studios that build on each other, you got 5 years left. There is no, you might only have one class a semester, but they have to build on each other. So when we look at that studio and the importance of it and kind of what happens to the industrial designer is it is a problem-solving process. And so each semester you're repeating that problem-solving process. Why is that important? Because within design, process is key. Process builds repeatability. It helps you get to repeatable solutions. And so that is why there's such a focus on that process. Throughout the process, as you walk through it, again, we talked about, kind of understanding that user, defining the overall problem. Then we move into the exploration piece where you're ideating, prototyping, testing. You get in the washing machine of, hopefully you do a few loops, but sometimes you can do a lot of loops. And then ultimately go to that materialize, implement phase. And I think in the school, it's much lighter on that implement side. There's little steps into it as, hey, how might this be molded? You don't dig too deep into it. But definitely once you get out of school, you go much deeper there. One of the things I wanted to mention too is it's been my experience as a consultant. You have somebody come in who's on a shoestring budget. They can't do a lot, but they need to develop something. And I've gotten questions like, yeah, that's great that you gave me that quote for 5 sketches, but how much for 1 sketch? And I think the only thing I wanted to sort of put out to this crowd is it's about the process. So pull down your deliverables. How do you shrink those deliverables, but you don't want to circumvent the process? Engineering side, math, lots of different, equations that make my head explode. I look at this stuff, and as I was putting this together, and just a very empathetic view of all the engineers around me. Just, man, guys, I don't know how you did it. But the interesting thing about their track is it's not this series of classes. There's some building, but it doesn't really follow a process. It's, thermodynamics at one point, dynamics at another point, statics and structures, these different pieces that you build on. It's almost, siloed math classes, and what we do see at that senior year, maybe you have a thesis where you're able to start to pull that together. And I find that very interesting, kind of talk about it in the case study I have in here, because a lot of our project management of our product development process is handled by our engineering team. But it's interesting, it's not what they do in school. So just to kind of summarize, these things we talked about, as I said, design from inside out, on that engineering side, that functional view versus the outside in on the design view. But the key thing being here is there's this overlap that happens between the two disciplines where function and experience kind of combined. And that's where the real magic happens, is that's where I always call it, like, this is this brand experience. You have this ultimate experience with ultimate functionality. And so when you're working on something, when you can have both the disciplines work together to really get to that final solution, that's the place to be. But I also know there's budgets, access to people, doesn't always happen. So I kind of put together a couple of case studies of how this has been I've seen this at my time at BOA over the last 15 years. When I came out here, I was the 17th employee, small startup, had a little place down on Platt Street. And, over the last 15 years, we've grown to have almost 300 employees globally, six offices, I think, Korea, Japan, Austria, U.S., China, 5. Anyways, I've been able to be a part of that growth from a startup all the way into mid-sized corporation. And so I wanted to put together a couple of case studies of how we approach these projects different based on where we were in our timeline as a company. First one, the S2 Real platform. This happened pretty early on in my career. The project team and responsibilities were pretty interesting. When I got hired on at BOA, I asked, and I kind of saw some of the work that was in front of me. I asked the CEO, why are you calling an industrial designer? This feels very engineering based. And the comment I got back from him was that I can teach a designer to mold parts, but I can't teach an engineer to be a designer. And so he saw that initial, like, we need to create experiences. We need to start with this big picture view, and then we'll dig deeper into those details. And so that's how he chose to apply the resources early on. So when we looked at the team responsibilities, as the senior industrial designer, I was responsible for project management, mechanical design, aesthetic development, UX, UI development, design for manufacturing. Really, it was my project, and I was able to get support in a few different areas. Mechanical engineering was one of those ones where I did get support, but it was more of design reviews, like, hey, me presenting my concept, here's where we're going, do you agree with this? As well as test development, it's a big one, like, how are we going to prove that this product works? So that fell on the mechanical engineer's lap. And then a tech technician who really just helped us through that field testing phase. At that point in BOA's life, it was very hard to do lab testing because we didn't have a ton of field testing, so we were spending a ton of time field testing. And since then, we've grown to connect those dots better, that now we actually have lab tests that replicate kind of what we've seen in the field over the years. Ultimately, we ended up, with an experience-driven features. Micro adjustability, being one of the biggest ones. At this time, all cycling shoes were loaded with ratchet straps, which I think they had 2-3 millimeter adjustment. It was pretty, maybe it's too tight, maybe it's too loose, but there's nothing in between. And we were able to drop that all the way down to a millimeter. So that was a new piece for people to really allow them to dial in to that fit that they wanted within their shoe. We worked on the UI, UX of the dial, making sure somebody could really get the input torque we needed. Mirroring of the system. So this was an interesting one. Difference between designers and engineers. I walk into BOA, and CEO is a mechanical engineer. We have a quality engineer who's a mechanical engineer. And we start talking about how the function of our product works. Okay, so on that right shoe, we turn the dial. And then the response I get is like, well, everybody in the world knows righty-tighty, lefty-loosey, so we don't need to mirror the system. We will just use the same thing on the other side. So now we're going to turn the dial the other way. And this was a real battle. It's like, no, we can't do this. I want to sit. I want an experience. I don't want to be able to do that. Luckily, through some testing and some really understanding the category, what we found was that because of the top tube on a bike, it's very difficult to kind of go backwards. It's also almost impossible to reach over and adjust. And so the mirror really became part of that experience that we had to build in. So it became part of the product. Refinement of the sound and haptics. Our previous systems, I would say they were almost toy-like, plastic on plastic. And as you can see from this photo, for some durability reasons, we had built little metal stainless caps, but it also gave us this nice little uptick in our sound and haptics. And then simple part replacement. Keep that in the back of your mind because that's going to come back up here in a minute. So what were the outcomes from this project? It really became this pinnacle piece within the cycling world. So for Specialized, I think at that time Specialized was maybe number 5 player in footwear. It really catapulted them to the top. We had interesting requests from pros that rode other shoes other than Specialized. This was something we developed specifically for Specialized. And we had pros calling us like, well, can you just prototype it on my shoes? And we're like, yeah, we can't mix the brands. That's not, per our agreements we have, that doesn't work. We got a Tour de France championship out of it. And obviously when you hit those elite guys and they are successful, people notice. And this is what started to change that cycling market. This was the beginning phases of us really evolving and moving that market from where it had been for quite a while. And for BOA, it really positioned us as that premium closure within cycling. So did anybody notice the bottom number on this page? because after telling you this story, you would have to think, well, that's how you should design all your products, right? Like these outcomes, boom, 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 boom. Warranty rate, 17%. We have an engineer in the house. What should a warranty rate maybe be?
Are you getting charged back?
No.
I won't go. 1%.
There we go. 1%. 1, 2%, I've heard both of those, but not 17. So ultimately in this project, we decided to prioritize the experience of the user over some of those manufacturing functional requirements. We thought if we provided a good enough experience, people would live through some of the challenges. And we also didn't see those challenges as huge. I mean, we definitely sat down and talked about them. These are cyclists. They generally do some level of work on their bike. So now we're going to ask them maybe once a year to replace the system on their shoes. We felt that was acceptable, and we felt moving forward with it. From a business standpoint, you don't want 17% though. Well, that was the problem we had of a prioritizing experience. But again, we started that movement. We started that change in the market happening. So now we're going to fast forward 10, 12 years and talk about the Li2 platform. So I'd say these happened roughly 10 years apart maybe. Now BOA is a much different organization. We're in that corporation, more of that corporation side, probably small business to mid-sized business. But now that team and those responsibilities have really changed. We now have a project engineer doing all the project management. We have 2 design engineers working on the mechanism within the product and also working on the tooling side. The industrial designer role has really shrunk to more of a traditional role focused on the aesthetics, UX, UI of the product. We now have test engineers. They're designing the tests. So our mechanical engineers can focus on the mechanism. Technicians still with a little different focus of actually executing those in-lab tests that we now are able to coordinate back to field testing. And then the final piece is a field test coordinator. Still always field testing everything we do, just to be sure. Now we're talking about functional refinement of the product. We've already established the use, the experience of the product. So now we were able to go in and really focus on function and all these little details that we wanted to pull together. So in this reel, the previous reel had micro adjustability. Our reels before that were turn to tighten and pop open to loosen. So if you went one click too far, you went one click too far. So we brought in this, now you can go backwards, but you can't pop open. This Li2 reel was the first time we were able to combine both technologies together in the footprint of what was previously just the incremental or just the pop open. So really refinement of that mechanism, bringing the best of all worlds together. Durability, unprecedented durability within this reel. And then the last piece, we're finally having a chance to focus on sustainability. Really looking at what can we do to help. At the end of the day, we're putting a piece of small plastic components on a piece of footwear. What can we do to help this overall problem that we have with sustainability, and really starting to be able to focus on that. Key outcomes, we get another Tour de France winner, always good. But a bigger piece is we have really just moved the entire market. 85% of the riders in the Tour this year are wearing BOA powered product. So complete real domination over what those top riders are doing there. And solidifying BOA as that premium closure system. Key number again, warranty rate. Full engineering team working on it. Now our warranty rate's down to 0.34%. That's where we want it, right? I mean, there's almost nothing there. You could argue that a lot of those defects are probably just within manufacturing tolerances of things going up and down. So we've been really able to dial in that, which helps ultimately kick back into, again, we want to improve sustainability. If we have a product that we're not seeing a high scrap rate, we're not throwing out a bunch of dials at the factory. So kind of back to the first piece we talked about here, which is the right individual to have on your project. Here's where everybody is upset because they don't get their money's worth. I can't answer that question for you. I can only just kind of provide you a little bit of a toolkit here to understand the backgrounds of each and how they can be applied. You know, I think there's a lot of things that go into it. The type of project you're doing, the people you have access to, the individual you work with. I've worked with some amazing engineers. I've seen engineers that do great sketches. Every person's a little bit different, so the people you have access to really can influence which is that right person as well. Anybody have any questions? Like I said, hopefully just providing a general toolkit when these decisions come.
Can you talk a little bit? Well, can you
I have to bring the microphone towards you.
the recording?
Sorry. Or I have to.
You have to.
Repeat it, that'd be better.
It's the law. Got it. Can you talk a little bit about manufacturing relative to industrial design perspective and mechanical engineering perspective, and thinking about how you get something manufactured and that type of thing?
Yeah, 100%. Good question. So within my design team that we have at BOA, whenever we produce a dial, which is the top cap that goes on our system that you adjust, that production CAD is delivered by the design team. There's millimeters between the inside and out of our product, so we really have to control that CAD, which means that the design team has to understand manufacturability. We have to understand, hey, do we need to do an open shut part here because that's going to give us better tooling capacity, you know, is it better going to give us better end cost and bring that down. So within the design team, it's almost required for us at BOA that you really understand the manufacturing process. Let's say you're not in a situation like that, so you're outside of that. So I look at the background I now have in plastics and molding and manufacturing and understanding of the tooling, and whatever I do in the future, the more you understand about the manufacturing process, the more you can design around those limitations. I've always said, like, hey, when you do a concept sketch, you know, this is the concept direction. We want to hold the idea of this as we work through. I've worked in situations where you're hoping someone else holds your vision while they make changes that have to happen. So as you understand the manufacturing process, you can create much better parts. And I see it as general problem solving. If someone tells me, oh, we can't do that because of this, then I can start to, if I understand the process, I can start to challenge that and say, well, could we, instead of, you know, what I've heard in the past sometimes is, nope, can't make that. Any other questions? I don't know if I can go that far. You might have to come this way a little bit.
Thank you. I'm just wondering if you collaborate with like the digital marketing, branding, design teams, or are you all siloed in your own world?
I will say we're softly connected. Whenever we're creating a product, right, there's some story that is building as we're developing that product, and we want to make sure that that story connects with the story we're telling. And so it's not a massive amount of collaboration, but it is making sure that we're all telling that same story. So there is some overlap.
Sorry if I missed some of the details, but could you explain more in detail what made your real system that much better than the competition that all the pros decided to switch over to it?
Sure. A couple different things there. We didn't go too deep into the details. You know, I think one of the things cycling footwear, it's all about weight. I mean, you might see next year's shoe come out and it saves 4 grams. So weight savings was one of the pieces we were able to bring. And then one of the other large pieces we were able to bring is most buckled shoes at that time were closing 2-3 millimeters. And we were able to drop that down to 1 millimeter of closure, or actually, 1 millimeter of closure. And today, I think it's actually even less than that. I think it's closer to a half, based on just the way our system is. So it really is allowing you to kind of fine tune that system right to where you want. The other thing, if you ever used a buckle shoe, it's a ratchet, right? Like your big ratchet piece, gross adjustments. You know, we were now providing pros the ability to back turn the dial 2 or 3 clicks, just let off a little bit. And what we found in their rides is that when they were riding in the Peloton, everybody's riding with their shoes loose, getting blood flow back to their shoes. I mean, one of the things, if you ever end up working with athletes, athletes have the worst feet in the world. It's like there's no feeling and they just destroy their feet. It's all about like, I want this connection and I don't care what it costs. Within the tour, we were allowed riders to be able to loosen up the system while riding, bring some blood flow back into their feet, and then crank that back down when they got to a hill climb or a sprint. And so that was a new experience that they had never been able to have during their rides. Good question. Anybody else? Cool. Well, if you have any questions, feel free to ask. Uh-oh, we got one more.
Can I switch it up a little bit?
Switch it up.
Okay. So for me as an engineer, there's always this question about quality design versus marketing. So what do you think has been more important in the success of this product? Or do they have to work together with some type of hybrid?
Another good question. I've worked in situations in my past life where it is marketing. It's a part of the real world. You know, it's something that's going to happen at the end of the day. When you have, when you're doing a coffee maker that's going to fall into a Walmart, it's kind of where I started my career doing some stuff like that. What's the difference? The difference is, is it 5 cents cheaper? It's not very glamorous, but there's some marketing buzz. I saw a little bit of that when I was at Remington. I think there were benefits, but some of them were question mark to me. We did a lot of coding stuff, like, oh, it's got this new nanotech coating, and I was always like, sure it does. So I've lived that side. It is a piece that exists, and it's just, I think that's part of the reality of the world. One of the things I really enjoy about my job now is, for us, our focus is on performance. And so much so that over the past couple years, we built an in-house performance fit lab, and we started hiring biomechanists. And so now we're scientifically looking at the benefits we're bringing to footwear in the different categories we work in. And I think for us it is, if we can, there's some categories that are a little more challenging. Oh, why do I really need this? And the reality is if you can take the top, one of the top golfers in the world and show that they're getting 5 more yards on a drive, that's a game changer. Or if you can show that someone on a running shoe might get 4%, 5% better efficiency over a marathon, those numbers really matter. And so now I've been able to mix real world results, and it's not really marketing buzz, which is great. Love that. I love it because it's much easier to talk about. Any other questions? All right. Thanks for coming out.